Inside the box. Or am I in a parallel universe? Inverted, beyond, back to front, upside down, turned around. Okay. I'm listening to, not the CB radio, but I was thinking, microphone placement. Where the microphone is where and how and what it picks up, receives, is listening to. Just as when seated. So, if I move forward, tonality of the noise on the CB radio here through a JBL Control 1 speaker. If I stand up, characteristic of the frequency changes. So it's where, it's like, how does a speaker sound in a room? Has anyone practically placed a microphone in one position, just one position alone, and then get a friend? Well, that person is observing and doing all the other REM, Room EQ Wizard, such, on the computer. You get a friend, place a speaker in a corner, do the frequency sweep, and then move that speaker with the width, the height, as it is, and then just move that one speaker along the side. We'll do the frequency sweep again, and then keep on doing it, repeating it until you get to the end, and then take a look at the frequency graphs. How do they look, and then get the friend and then play pink noise. So he's standing just underneath the speaker, so he's not in too much of the way to interfere with it too much. And then move that speaker slowly along the side, along the top of the where because it is a room, and just move it slowly and then slowly and slowly and slowly and so on and so on until you're up to about, boom, up there. And then come back and then go down one speaker down, the height of the speaker, so the speaker's so high, and then go down one step lower, one step, and then go along the side, repeat, and then do it until right down to the bottom, and then cross until you've done that, and then you do it across that way and the other way and the other way. And then maybe start with the speaker on the floor facing upward, and then move it along the floor, up and down the floor length and the floor width until that's completely done. And then do the ceiling, and then that the speaker's not too bad. You can see where with the, my goodness, how many REM frequency sweeps would that be? It depends on the height of this, depends on the dimension of the speaker, it depends on the length, height, width for the room. Let's just say for this room, it's a small bedroom. Gosh, it's easily. Well, it's easy to work it out because all you do is do the math, speaker dimension, measure, and then do the calculation, and then you would need it. The measurements that are going to be required would be this amount of 500 speaker placement measurements, say, for argument's sake. And it's like, oh, gosh blimey, I think we're going to be here for a few days doing this. You're going to take a break and come back and then resume. So everything will be left in the same position and then resume. It will take days to do it. And then, once that bit's done, this is where it gets a bit more fun. Then, say, so to speak, because I'm making this up as I go along, be ready for me. I'm going after that truck. How? I don't know. I'm making it up as I go along. Dun 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 dun. Okay, so just say, like, pretend that's a speaker, okay, and then you're gonna have that speaker up in the corner. I think it's going to be up there in the corner. You're going to move it along. No. Oh gosh. Where to start with this one? Because this one would be very complicated. I suppose if the microphone were in the middle, start with the speaker close to it, and then gradually say that the depth of the speaker, that's it, the depth of the speaker, and then just move that back each depth. And maybe that's a little bit too much. I think that's a little bit too much, to be frank. I would gradually move that speaker back every, well, to make it a real pain in the arse, I would move it back every single 1 millimeter. Because when you think of everything here, it is tiny particles of, that make up sound. Being disturbed particles, and then reflectivities, and they come back to your ears, and then perceived as if I were to pump air pressure into the room, and then will it vent? I'm guessing it would. I'm guessing there somewhere around the PSI is dropping. It's venting, and where at, Doesn't mean to say that I think a speaker has to be sub-bass pressurized and all that, because with what I've noticed is infrasonic low frequency. I noticed by, say, open the door a little bit, not too much I notice there, nothing really dramatic, and then suddenly I open the window to the room. Oh gosh, I've just seen anywhere, depending on how much the window is opened up by, I see anywhere from 2 to about 4 dB increasement in the infrasonic low frequency at a specific sine wave. And I'm thinking, oh well, I'll take that, any increasement, yeah, I'll take that, so my JBLs, they can do it. But they have their excursion limitations, they're fun, But if you had any other sub that can manage the excursion, and you don't have to have it going like stupid, just normal, and then think, oh, that's not too bad, and then increase gently 1 dB at a time or something, whilst going through to check the other frequencies, because as you get up close, because theoretically the frequencies on the sine wave should be flat across. Literally, they should all be equal, flat across the scale, but they start off down here in the infrasonic, and it goes up until you're up to near 20, because you've got to do a frequency sweep of your sound card. Does your sound card have a roll off? If it does, then your processor, does your AVR processor have a frequency roll off? So you need something to test that that's got a flat frequency response on its, and then you test it with because if I were to test the AVR onto the computer, I know the computer's got a roll off on the low frequency. Every computer sound card is going to have a bloody roll off. So each and every different sound card or whatever, it's going to have that specific roll off. They're all going to be different, yeah, and not all like internationally standardized. They're all going to be a little bit variably different. I would rather prefer there was no bloody filter there and it would just run right down flat. Yeah, because it's like undiscovered country, the infrasonic low frequency, you know. It's not the final frontier to, no point going above 20,000 because our hearing just rolls completely right off. But that doesn't mean we can't feel something that might be there. And you shouldn't really go too far with it, because if you start going too far with it, then you can start messing your body up, and then you're going to be regretting what you've been doing for so much duration of time, because it's like white finger. White finger is where you use mechanical drills and such and so forth, drilling and so forth, and you do that 8 hours a day, 10 years or so, say, for argument's sake, and you just have you just can't close your fingers up. Everything in your muscles, the coordination is completely messed up due to the excessive use. Now, I've done tests using sine wave, putting my fingers on the bass driver, playing specific sine wave low frequency for as much as, I think, a couple of minutes or so, and I'll take my hand away and I get a kind of tingly effect. So you imagine doing that 8 hours a day, 10 years, you're gonna have, you're not going to be yourself. You're not going to be, and they're not going to pay up compensation or any bullshit like that. Fuck it. You've done the work for us. We paid you. Blah blah blah. Tough luck. Oh, is that how you feel about it? If you do that with too much sub bass, frequencies where eventually they're going to damage your eardrums. No if, no but, no debate, no vote. They will damage your eardrums. It's only so much, you can take. Playing high frequencies at extreme high sound pressure level just to perceive it. I mean, if you can just about pick out, I can just barely, faintly, 18,000 kilohertz, it's teeny. And all I get is an effect of like pulling a face like that, like, ugh, because I can feel the sound waves coming down on my ear membrane, causing a kind of physical pain. Now, if I had perfect hearing that was absolutely bang flat and played that sine wave at the increased level, I would have instantly go like that and go, fuck. You play a sine wave easily as 8 kilohertz, and it's at a high level, and you go, fuck. You play it at a softer sound pressure level, and it's like, yeah, that's okay. But when you start going above 8,000 kilohertz, my hearing starts, yeah. And then you got to orientate and move your head around and do all this sort of shit. Where's that speaker placed and all that, and can you still perceive that sound? Put the headphones on, it's going to be there, because the sound going out of the tweet is going out in all different directions, and it's going to reflect off random, complete random objects, surface objects, and it's going to not come back at your ears quite at the same time. It's going to be like, it's over there, it's a null, it's a dip, bloody hell. You go up close and listen to it, but play at a soft sound, turn this volume down and go up close and then listen, and it's like, yeah, I just hear that, yeah. And then you move a little bit, and then say, like, have someone move that speaker a little bit further away each time while still listening, and it's like, no, it's getting a bit faint now because it's dropping off, it's going faint, like listening to radio stations, and sometimes the signal comes in strong and then it just fades out due to the skip, the conditions, and it just suddenly it's up and down all the time. Yeah, you get someone move that speed, and then okay, we'll increase the sound pressure. We'll take it up an extra 1 dB. Yeah, I can still perceive it. Move it back a little bit further, and also I think the distance. Due to every distance, you have to put a specific increasement. But if it was done in a way, you know, for the say specific driver, whatever, until you get like, yeah, I can still perceive that. I can still perceive that. Okay, yep. That's good at that frequency. And then you know all the other frequencies below it are going to rip your ears off. They're going to be too damn loud. You need to attenuate those frequencies bit by bit by bit. Every single bloody sine wave tone needs to have its own, not literally its own, but I think it literally its own PEQ. And there's just not enough PEQ. The most PEQ I've seen, I don't know if there's others out there, if there's others out there that are all in one box and it covers literally from 1 hertz up to 20,000 kilohertz, and it would do every single bloody sine wave tone frequency known to man. And it was cheap and affordable, of course, because I believe it should be, because audio's just been around for such a bloody long time. I think making all this bloody stupid, bloody snake oiling bloody money out of this fucking thing is just absurd and greedy. When sound is absolutely free, and still all you're listening to something at the end of the day is a fabricated bloody recording mix. You need a frequency box that can do every single. Now the Behringer FBQ 2496, you just about dial in just any other. You can just dial in any frequency, but the most it would do is 40 parametric EQ filters. So you daisy chain channel A into channel B, and then you got 40. And if it still don't cover enough, because you go through every frequency, right, and count how many there are, yes, which is quite a bit. And then you work out, right, I'm going to need so many FBQs daisy chained just for my left, my center, my right, my surround channels, my overheads, below surround, up, and for your sub bass, you only really need one FBQ daisy chained channel A to channel B, so you get about 40 PEQ filters. Not that you may need them all, but it's there. So roughly, but an FBQ can only go 20 hertz up to 20,000. So it's not going to do the infrasonic. For that, you're going to need another box. I think there's a few other boxes that do that. When looking at the Room EQ Wizard EQ equalizer thing, it gives them a list of that you can go and buy. And there's some boxes that can do infrasonic low frequency. So if they could do infrasonic, that means they could do all the individual frequencies. So you should be able to dial in. I don't know, it depends. And if you work it out, and then you think, right, I'm going to need so many of these mini DSPs, daisy chained, to cover every little bit in through the infrasonic range, 1 hertz at a time, because they're like one hertz more or less at a time. I think they do have slight decimal points on the REM. I think it's like, I think it's 0.5 dB decimal step. So if you want to get clinically precise, then yeah, fine. But you need quite a few of them. So now I'm opening a whole new can of worms. So everyone now is going to go out and buy a bloody load of daisy chain their mini DSP and then go through every single frequency. Unless you can really realistically get your sub bass to go start at 1 hertz and then 1.5 and then 2, 2.5, and so on and so on and so on until you get up to 20, and you dial in until it's absolutely smooth on those frequencies, even though realistically we know it's rolling off because the AVR is going to have a roll off on the low frequency on the low frequencies, the computer sound cards. So you got to kind of like, in a way, sort of work out the simplicities of, I wouldn't call it mathematics, I would just say if it's got roughly that sort of roll off, then you just got to kind of predict what it would be like if it was flat. Okay, and then once you've got that figured out, and then do the sine wave and test, and because it should also measure the same way, even if you're doing it directly onto the computer from your output from your AVR. It should all measure boom, 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 flat along the line. And then you can start adding in filters, PEQ filters, and say, oh, these frequencies are just too damn harsh, you know. So I'll just put PEQ filters here for equally for LCR, the surrounds or such, and then just widen the Q out and then just drop it down a little bit, just so it sounds not too harsh. It's okay on these frequencies, these other put a PEQ in there and just bring that down, and then give a movie a listen to, and it's like, does that kind of sound like a breath of fresh air or whatever, or does it sound like, it doesn't sound too harsh? It's got a lot of energy acoustically that is felt, and clarity in through the other screen channels through to the surrounds, of not being too honky sounding, where it would be probably around 300 up to about 500 hertz, somewhere around that range. Some frequencies can sound a little bit honky, and kind of bring it down so it's not, you know, because unless we go around with talking like this, like, you know, talking like, yeah, like that, you know, and it sounds what? It sounds honky. It sounds like you got a tube over your mouth. I do. So yeah, it's just working that out. It's not a big deal, but it is, you know. Yeah, so if I play FM, which sounds like white noise, just move around the speaker about this distance. Now, of course, I had to lean forward a little bit when I was moving the microphone around. So I'm going to play back the video when I do that. I only have to do that once to listen. I'll play that back because I had to move slightly forward because I heard, because it's just like... you get that effect. It's the same with acoustical transparent projection screens. When you put a speaker behind the screen, it's going to do a certain, you know, and it's just simply, all you do is simply working out how close each 5 screen speakers should be placed behind the screen 5, because usually that's a minimum of a basic that's been around since the 1950s. It hasn't really much changed since then. So you place them behind, so you know, and then checking the EQ, obviously, with real-time RTA, pink noise, and then do a frequency sweep afterwards to see what little things are missing, and then it's just maybe a case of maybe just move that speaker a tiny bit, you know. Everything's got to be measured, you know. And then, of course, then you got angles, and then you got tilting. You got angles, and then you got the tilting. So usually the horn, HF horns, they got a good dispersion, vertical and horizontally, diagonally, inside out, turned around, back to front. So they got usually a good CAD dispersion, and all you have to do is just simply just tinily just move it, because if I listen to the white noise from the FM, and just move slightly like this, that's not even barely an inch. I'm probably maybe going about half inch. I can hear the sound kind of going, it's wobbling effect. Yeah? Film soundtracks are kind of precisely mixed within a tolerance of a few dB as such. So, you got to have everything set up. So it's, yeah, it's not a big deal. You place objects near a speaker. If I place that near the speaker, I can hear it sounding like the sound is going into the glass. I'll do that again, see if you can pick it up on, see if this picks it up. Do it for the high frequency. Now it's a little bit difficult because the angle of the glass is cutting over this angle slightly. So unless I got the bass driver disconnected and just a tweeter sounding, otherwise it's a little bit difficult to notice, to distinguish. Cheers. So that's kind of like cinema sound engineering without the bullshit, if you know what I mean.